Hello again. From the previous video, here's a problem I'd like you to do for yourself, 1 over Radical72x. Take a minute to do that if you've not done it already from the previous video, just the one we just finished. But anyway, if you've already done that, great. If you've not, do so pretty quickly. So let's move on. Let's look at this down here. 12 over radical of 45x, the x inside. Now remember, the big 9 is the biggest perfect square that goes into 45. We take the 9 out, the square root of 9 is 3, so it comes out as a 3. That leaves 5x inside. Remember 45x, you go through this step up here. This is the step that I skipped. You know, I displayed it up here. I didn't display it down here. You can stick it in here if you like. I'll do that just for the sake of completion. So you got 12 over... I'd like you to get to the point to where you can sort of see what's going on a little bit, you know, or just see it ahead of time. And I think many of you probably will. So, but I'll play it safe. I mean, it's no problem, you know. I don't mind. So there's that. So there's a step that I skipped, and that 9 comes out as a 3 right there. Okay. So now 12 thirds is 4. Remember, 12 over 3 reduces to 4 over 1, which is 4 itself. 12 thirds is 4. And so really, I could go ahead and just do that here. That's a 4, and then that 3 just becomes a, well, going down. It's a 1, but 1 is understood. You can put 1 there, but it's usually understood, so we just erase it. So now, so we got 4 over, and well, that's a step. I skipped that step. Maybe I don't want to bog you down. What's going on is that's just 4 over understood 1 radical 5x. The 1 is understood. So if we got 4 over, the 12 thirds reduces to 4 over understood 1, so it's 4 over radical 5x. But then we stick, now notice our prototype is radical 5x, so we stick another radical 5x here, and to balance that we stick 1 upstairs. But then radical 5x, all variables is positive as always. That's 5x. And so we get 4 radical 5x over 5x. And, well, that was redundant. Let me just get rid of this guy. Now I'd just stop here. Now if your professor insists, you can tap it as 4/5 times radical 5x over x. Or, actually, this is, if you must fragment, I'd probably fragment it like this. I'd bring the radical... You can put the radical 5 here and the radical x here. So you'd have 4 radical 5 over 5 times rad x over x. By radical, I mean square root. But I would, to be honest, guys, I would leave it like, like this right here. Sorry. Everything's going crazy on me. Yikes. Sorry about that. I would leave it like this guy right here. Unless your professor just insists otherwise. This is a little messy. This is probably not even advisable right here, but I'll leave it here. It's correct, but it's kind of messy, sloppy to me. But anyway, this is just more to show off that you can tap it like this if you really wanted to. I don't think you would. Let's move on. Now, what if I have sort of the same thing, but I have, instead of x in here, I have x squared, and all variables positive? Well, notice this time what's happening in this intermediate step here, that's 12 over, and on the bottom, I'll have radical, and well, and let me try to get it. Now notice x squared, 9x, you can take out x squared. Let's put the x squared with the 9 because it's coming out as well. 9x squared comes out as 3x, or the x is of course positive. So we got the 9x squared comes out as 3x. So we got 3x in the radical 5. So we got 12 over 3x radical 5. So my prototype, the only thing in a radical is just radical 5. So the only thing I need to stick down here, you know, after the fact is radical 5, here and here. And to be honest, it's good. It would be good if 12 thirds is, of course, going to reduce to 4. I kind of delayed doing that. I wish I wouldn't have, really. Let me go ahead. Let's just go ahead and reduce. That 12 thirds is 4 over 1, which is 4. So we just have 4 over understood 1 and x radical 5. Okay, and I'll need to, just to avoid a mess, let me scoot that down. So let me scoot that downward. It's going crazy. Let me see. And let me, guys, I'm sorry, let me scoot this down. Everything is going wild here. So let me try to scoot this down. It's been a little rebellious, to say the least. Okay, and let me do that. Okay, so let me start. Let's go back. So I got 45x squared. I do 9x squared times 5. The 9x squared comes out as a 3x. The 12/3, well, after that'll reduce to 4 over x radical 5. And, but no, so this is a 4, and that 3 is just gone to 1. So, but now you stick a radical 5 here and a radical 5 here. We only need radical 5. But because that radical 5 by associativity, that'll make a 5. We'll have x times 5, but it's cleaner and better manners to put the 5 in front. So that's 5x. And then the 4 radical 5 up here. And I would leave it like this. Yeah, you can type it like 4/5 times rad 5 over x, or you could more neatly do 4 rad 5 over 5 times 1 over x. But I would just leave it like this guy right here, okay? It's just cleaner and neater to look at. But anyway. And if you have x cubed, now remember the step that I skipped, you want to turn x cubed into x squared times x. So in particular, you got the 12 up top, and what you got is you'll have the square root of, then now you want to get 9x squared, which is a perfect square. It's going to come out as 3x. 9x squared times the 5x that cannot come outside. And this again is messy. Let me scoot this OR command down. It'll take it just a minute to get down there. And then oops, let me do that. There we go. So I got 12 over radical 45x cubed. Remember that, so that you turn that 45x cubed into 9x squared times 5x. That 9x squared, all variables positive, comes out. 9x squared comes out as 3x. X is positive. So we got 3x radical 5x. Now this time my prototype is radical 5x because I do have that x inside of the radical. So I got radical 5x, but if you stick a radical 5x down here, as always, you got to stick one up here. But then, now guys, something I should have already done, that 12/3, let me go over here. That's going to just reduce to 4. Well, I need to, that's going to be 4 over 1. So let's just go ahead and reduce that out to 4 over 1. And let me insert that other step and do that. So that 12 over 3x, before I ever conjugated, let me just reduce. Sometimes I think it's better to reduce before you conjugate. You don't have to. But it's just nice. So if I divide this by 3 and this by 3 before I ever conjugate, I get 4 over just x radical 5x. Notice, by conjugate, I mean, when I say conjugate, I mean stick this other radical 5x here and here. That's conjugating. But before I ever conjugated, I just reduced right here, okay? And then I conjugate by doing this, but, to counterbalance that, I got to do this. So here's the conjugation step right here. And then rad 5x times rad 5x is 5x itself. But guys, x times 5x is 5x squared. So I am a little concise there. This other x is going to make this 5x squared down here. So I got 5x squared. So I got 4 times radical 5x over 5x squared. I'd just stop there. If your professor insisted, you could type it like this. 4/5 times rad 5x entity all over x squared. Or more neatly, like this, 4 rad 5 over 5 times radical x over x squared. That's okay. I'd rather, to be honest, I think this is the neatest form, the most appropriate right here. Okay, so just stop there. Okay, we have finally made it through those. Now, what if you have a radical plus something on the bottom? That's messy. So let's look. If we have like 1 over 5 plus radical x, here's what you got to do. We're going to conjugate, or the conjugation step. It's a little bit different this time, but not really different. What you do is we already had 5 plus radical x down here, so you need to stick a 5 minus radical x down here, and you got to put parentheses around both. You do need these parentheses. Now, I've not justified why we need the 5 minus radical x yet, but just trust me. Now, if you stick 5 minus radical x down here, you got to stick 1 up here, and we just multiply it by 1. If that was a 2, we'd have to distribute 2 through this, and we'd get 10 minus 2 radical x, if that was a 2 right here. But it's not. So it's just 1 times. The 1 doesn't change anything. So we multiply the top and bottom by 5 minus radical x. And we get 5 minus radical x over. Now remember, by difference of squares, a plus b times a minus b is a squared minus b squared. So where a is 5 and b is radical x. So we got 5 squared minus the square of radical x. And yes, you do need these parentheses. But now 5 squared is 25. Oh, if you square the square root, that's just x itself. All variables are positive as always. So we got 25 minus x on the bottom and 5 minus radical x on the top, and we're done. The whole point of all this, everything we have done, is to get the radicals off the denominator, to have no radicals on the bottom. Okay, that's what all this stuff has been based on so far. Okay, get the radicals out of the bottom. That's what it means to rationalize the denominator, to get the radical out of it. I really should have told you that earlier. My bad, but that's what it means. So to summarize, I multiply the bottom by 5 minus rad x and the top by 5 minus radical x. And just for the sake of completion, allow me to do something, if I might, real quick. I'm going to insert another example. What if this would have been a 2? Then you would have just had 2 times this guy right here. Excuse me while I type. So we got 2 times this guy right here. And then you distribute the 2 on through, and you will get 10 minus 2 radical x over the same denominator. Notice the denominator is not going to change. The same stuff happens. We just got that 2 that we had to distribute up here. Okay? So there's that. You just have this 2 and you have to distribute it through the numerator like that. So it's not really that big of a deal. If you had an x up there, or if you had x plus 5, you would have to do FOIL or distributive. You just have to multiply it. Like the 2 was pretty simple, you know. Let's look at this next example. 1 over 5 minus radical x. Well, this time you stick 5 plus radical x down here and up here. You already had 5 minus radical, so the 5 plus radical is the new thing, so you got to put it down here and up here, okay? Now again, for the same, you'll have the same denominator just like you had before, but this time upstairs you got 5 plus radical x is the only difference. You started out, instead of 1 over 5 plus, it's 1 over 5 minus, okay? But anyway, there's that. And again, if you want to stick a 2... Oh, I did that here already. Sorry, I didn't know I'd already done that, but it's all right. There's the same old example. You know what? Since this is same old, why don't I spice things up? Why don't I do 2... if I do 2x cubed. Well, what that's going to do for me, it's really going to be still pretty boring. That's just 2x cubed. And so you're just going to have, what you're going to have is you're going to distribute 2x cubed through. That's just going to be 10x cubed minus 2x cubed times the square root of x. And then, guys, that 3 is dangerously close. I hate to put a time sign in. If this was pencil and paper, I wouldn't have put this time sign in here, but let me do it just so that doesn't look like the cube root. See what's happened? This 3 looks like it could go with this radical. It does not. So that it goes with this x right here. This is x cubed. So we're doing x cubed times the square root of x here. So if this is pencil and paper, I wouldn't need the time sign. But on Word, I kind of do just for neatness, not out of mathematical necessity, but out of neatness. So there's that. And then we'd have 10x cubed minus 2x cubed radical x. And really this is good, but out of neatness, I'll put the times sign there, okay? And I'll save it. Like that, okay. So there's that. Now let's say I don't have x's. Let's just say I got numbers. Like 1 over 5 minus radical 3. You just stick the conjugate 5 plus radical 3. Notice with conjugate, we only negate the middle. We don't negate both terms. We only negate the radicals. So we got 5 plus radical 3 here and here. And then you're going to get difference of squares. The whole point is to get difference of squares, and that's going to kill the square root guy on the bottom. So we're going to get 5 squared minus the square of the square root. Notice that square is going to kill that square root, just leaving that 3. That's what it all boils down to. You're going to do difference of squares down here. You'll get 25 minus 3 is 22, and you'll get the 5 plus radical 3 up here. surprise, surprise, no surprise at all. Now, what if I decide, let's get miserly, though. What if we cause some trouble? Let's say we got a non-trivial numerator. Instead of a 1 or a 2, what if we got something like 5 plus radical 3 itself over 5 minus radical 3? Doesn't matter. The only thing we want to conjugate is the denominator. We don't want to conjugate the numerator. Well, there'll be situations in calculus when you'll conjugate the numerator, but let's not do that here. So 5 plus radical 3 over 5 minus radical 3, you conjugate the denominator. So you stick a 5 plus radical 3 down here in order to get this difference of squares. But if you multiply the bottom by 5 plus rad 3, you got to multiply the top by 5 plus rad 3. So, but notice there's already a 5 plus radical 3 up here that from the beginning, so you're going to have 2 of them. You're going to have 5 plus radical 3 times 5 plus radical 3. Remember, that's just the square. You're multiplying something by itself. Okay? Now, you'll do distributive FOIL. Now, upstairs, I kind of skip a bunch of steps on the numerator, not so much the denominator. The denominator is no surprise. We just get 5 squared minus the square of radical 3, which was the point, was to, oops, sorry, my bad, hold on. That's not a 3 there, that's a 2 there, my bad. So we got that. Now, up here, if you multiply 5 plus radical 3 by himself, this is correct, but it may be by FOIL. Let me type my steps as I go. If you're good with FOIL, don't worry about this. You'll be bored. But if your FOIL is rusty, I hope it's not. But if it is rusty, then follow along, please. Okay. So what we'll do is we'll do distributive FOIL. Now I'll just insert another step. So now on the bottom, I'll leave this. You could go ahead and do the bottom if you wanted to, but I'll leave it be. I mean, you can go ahead and do it and get it over with. There's no point in really my delay. I'm just worrying about the top, kind of. So let's do distributive FOIL. First, outer, inner, last. Or you could just do distributive. You could skip FOIL and do distributive if you'd rather. Whatever, if you'd rather. So by first, outer, inner, last, my first terms, 5 times 5 is 25. My outer is 5 times positive radical 3. That's plus 5 times radical 3. I did the outer. 5 times rad 3. This guy right here times this guy right here. Next, I do my inner. I do this inner radical. So it's positive radical 3 times 5. That's another plus 5 radical 3. And it's a little slow there. And then now for the last. Now, guys, plus radical 3 times radical 3. I'm going to go ahead and just cut to the chase. Yeah, that's radical 3 squared. Guys, that's just 3 itself. It's radical 3 squared is radical 9, but what is the square root of 9? 3 itself. Okay, and you know what? This is silly. Let me go ahead and get rid of this. Let's fix the silliness down here. We know what 5 squared is. That's 25. No point being silly. And we know what the square of the square root of 3 is. That's just 3 itself. So again, there's no point being silly. And we know that 25 minus 3 is 22. So let's not be silly about it. So let's just go ahead and put 22 down here. Now, and we know that we upstairs we're going to add like terms. 25 here plus 3 here is 28. 5 rad 3 plus 5 rad 3 is 10 rad 3, like that. So, and then, well, what have we got? We got 28 plus 10 rad 3 over 22. But guys, what we can do is we can factor a 2 out of that numerator, because we can tell stuff is going to cancel. We factor a 2 out, and that becomes a 14, and that becomes a 5. Now, if that 22 on the bottom were not, if it wasn't even, this would not be all that fruitful. But it is even. Now, so we get that. Now, guys, you see that 2 and that 22? That's going to reduce to 1/11. So what's going to happen is, let me get rid of this guy. I don't need this guy anymore. What's going to happen, I reduce, this 2 becomes a 1. 2 goes into himself 1 time. 2 goes into 22 11 times. So I just get, so that just liberates the parentheses here, and I get 14 plus 5 radical 3 over 11. And that's the final answer. This 2, remember 2 over 22 reduces to 1/11, where the 1 is understood. Guys, I'm out of time. That'll be all for this video. Thank you.